Hello, my name is Jim Junior Mengana, and my presentation is titled Binary Thoughts Exploring if Computers Can or Will Ever Be Able to Think. So, recently in the field of AI, there has been massive developments, and this was actually triggered due to the discovery of the transformer model that resulted into the generative AI models, and later on brought up the rise of large language models. And with a brief interaction with these large language models, they tend to produce output that mimics human behavior or human thought, process of thought. And this output, if you interact with them, one can aim to ask, are these computers really thinking? And or are they actually just mimicking our process of thoughts through these advanced mathematical models that are powering them? And if they are not thinking, shall we be able to create computers that can be able to think with time? So through this presentation, we are aiming to answer this question, and we shall base off a conceptual AI platform, which is a virtual event touring platform, and we shall use it to analyze these questions and come up with a conclusion. So a brief go through this virtual AI powered platform. So it's a virtual event touring platform that is produces immersive 3D experiences basing off, let's say, past events that happened, and it uses that data to generate upcoming events or previous upcoming events, and creates this immersiveness through 3D reconstructions and reconstructions and predictive simulations, interactive features. So we assume it's using generative AI to generate this preview 3D immersive environments. So to answer the question of can computers think, we have to first analyze what thinking is. So when you think of thinking can be, in broader terms, we generalize it as thinking in animals as a whole or in living things as a whole. And I mean living things that have a complex brain that is complex enough to carry out the process of thinking. So as a general definition, thinking is manipulating information, and this can be information got from sensory inputs and using it to solve problems. So we manipulate the information to solve problems. This is more of like a general broad-based view. So think of, let's say, a human trying to solve a mathematical calculation, a predator trying to come up with a plan on how it can attack its prey, or a prey coming up with a plan on how it can avoid predators. That's all like thinking. The first thinks, the first manipulates that information. So, but on a human-centric point of view, thinking is a specific cognitive process that involves conscious reasoning, problem solving, and creative imagination. What that means is that to us humans, it's more of an intentional cognitive process that we embark on. That's like thinking. That's the way we experience thinking. And from these two definitions, we can basically try to analyze thinking as in two ways. One as a subjective process with subjective experience, and also analyzing it as a functional process. In this, we are looking at the functional steps that go into thinking. So let's look at thinking as a subjective process. So what we mean here is that thinking as a subjective process is we're looking at the subjective experience or a conscious experience that we embark on. So think of how we what I mean by this is that this is an experience that we go through intentionally as living beings, as conscious beings. So one way to think of this subjective experience, to try to explain this subjective, is if we look at our virtual event touring platform and we look at the immersive experiences that it creates. Does it really understand this experience? Does it understand the meaning? If it generates a mountain, let's say a view of a sunset, does it understand the experience of the sunset, or is it just generating random ones and zeros that encode certain information, like it doesn't really understand what it's generating. So to us humans who are experiencing the sunset, we understand the meaning behind, but to the system, it does not really understand, it doesn't really experience the sunset that he has created. So that subject, that thing, that experience is what we call the subjective experience. A simplified way is, for example, the of a blind person who has never seen the color red, but has read about it and knows all the scientific properties of the color red, and a person who doesn't really know the scientific properties of color red but has seen it. So the other one understands the information about red. This one has experienced what the color red really looks like. So the experience of seeing the color red, the experience of seeing the sunset is not the same as knowing information about the color red, or our system being able to encode a sunset into some ones and zeros that represent a sunset. So we can also look at it as and actually this process is termed as qualia. That kind of experience, those qualities of experience are termed as qualia. It's a term that is given to trying to simplify, to explain that subjective experience. So a simpler way to actually look at it is if we focus on the Chinese room argument, which is a thought experiment that was created by John Searle. And in this thought experiment, he's taking a person that doesn't understand Chinese but has a rule book that he can follow to translate Chinese from another language, and from that to translate to Chinese from another language, and also translate from that language, from Chinese to that language. So to an outside observer, the person inside actually understands Chinese, because you can pass him a note in Chinese and he replies you in Chinese, but in actual sense it's just translating it from Chinese to a language he understands, and from the language he understands to Chinese. Yeah. So if we look at that, that means that our systems actually don't have some kind of, let's say, subjective conscious form of thinking. They are following a rule book, which are the algorithms and the data patterns, to create a simulation of what thinking looks like. But then if we look at the functional point of view, whereby we look at the process and does it achieve its goal. So if we look at, for example, let's say a human who is thinking, he follows his brain internally follows a certain set of steps and produces a certain outcome. Even the systems follow a certain set of steps and produce the outcome. So if the systems they might not follow how brains work, but they all do some kind of computation and produce an outcome, and our brain also does some kind of computation and produces an outcome. So if I look at it that way, does that mean that computers actually thinking, but maybe in a different kind of thinking that we don't really, that is not similar to how humans work? To actually explain this further, we can base off the Turing test, which is a thought experiment by Alan Turing, whereby it was like, we can call a machine thinking if it can create an output that humans cannot distinguish from if it's a machine or a human. So for example, if our system can produce immersive experiences that are indistinguishable from reality, then is our system actually thinking? Or if the LLM that you're talking to can give you a conversation that is indistinguishable from a human, does that mean that the LLM is actually thinking? So if you were to focus on the functional standpoint, it would seem like it's thinking, but in actual sense, it's not really thinking. These are just mathematical models that predict, that mimic thought. And one of the other main reason is that these systems are usually limited in scope, so they can do one thing really well, but generalized, take it to another kind of process, it won't do. And actually, we term them as a weak AI. So my verdict is that these computers really don't think. They basically just mimic thought, and they don't really possess any genuine chain of thought like actual humans, or the kind of thought that we humans experience. But then, if they don't, does that mean that we shall be able to create systems that are able to think? So this question is really hard to solve, mainly because thinking is more of a is one of those mental capabilities or cognitive capabilities that is tightly tied to our biology, emotions, consciousness, and different aspects of our biological existence that we don't really fully yet understand. For example, consciousness is a really core part of our is a really core problem that is not yet understood scientifically. However, some scientists really argue that with time, these systems will kind of gain these properties as emergent properties. For example, they believe that consciousness emerged as our brains became more and more complex. So, say our systems become more and more technological advances, for example, in algorithms, in terms of the data, the quality of data, and computational progress. This kind of, let's say, consciousness and all that might kind of emerge. That being said, I believe that since thinking is part of the brain, which is a physical object in the physical realm, the more we understand about how our brain works, we are rest assured that we shall be able to create thinking computers, because the brain is a physical object defined by physical laws which we can study scientifically and understand. So it might take time, but it will happen. We shall be able to create thinking computers. And lastly, we should look at why these questions matter. Why should we ask if computers can think? And one of the main reasons is we have to look at their impact, their implications of creating thinking computers. What implications do they have to the socio-economic workings of the world? So, for example, first of all, we have to look at, take an example, if our system, let's say the VETP system triggers PTSD, and to a PTSD patient, and that person is shown some really triggering images, or what? Who is to blame? Is it the programmer? Is it the AI? Is it the company? Is it the patient himself who, let's say, prompted the system to do that? So if we ask these questions and we know if the AI is thinking or not, we can really be able to track down who gains the moral agency, who is in charge, and who is to blame for such mistakes or errors that occur with having thinking AI system. But also, if we look at the systems themselves, if a system is considered thinking, does it have rights? Is it right to shut it down without its consent? Basically, having made it doesn't mean that you have to shut it down. Just like having given birth to a baby doesn't mean you have to kill the baby. You don't own the rights. So we need to look at these questions in deep so that we can approach AI systems responsibly and with some form of moral agency, and we can, to prevent mistakes or unwanted consequences like other scientific advancements cause, say, nuclear bombs and all that. And that being said, I come to a conclusion saying that currently computers can't think, they just mimic the chain of thought. But the more we understand about how our brains work, the more technological advancement that we gain, we shall be able to create thinking computers. It might take time, but it will happen. Thank you. That was my presentation. Thank you.